Okay, so this is it, right? Yeah.
Hold on, I'm going to spotlight you now.
Okay. Oops, pleasure.
You said what? Wait, come on, that's what I'm trying to do. I'm trying to make you spotlighted for everyone. All right, this makes sense. But then as you are writing, this makes sense. Don't worry, this makes sense. So as you are writing, you know, I see your small writing for crying out loud.
No. I'm not supposed to read out what is here. Then when it's time to solve, I've solved it, so it's kind of clear. Yes, this one should be better. Then I can still resolve after reading.
And you can even, you are still going to we have to scan this note and send to the group that solution that you saw. So that
all right,
you get.
Who can see it?
Let's just wait for people to join. This is 3:38, so let's give them about 5 minutes to join, then we commence.
Okay.
All right.
Okay, this is 3:40. I guess I can start now.
All right, wait. Just a minute, Seyi.
All right.
Okay, I think we can move ahead. Others will probably watch the recording. Yeah.
All right, then. Good afternoon, everyone. And for our tutorial today, we'll be learning about CBR value calculation using pavement design. The CBR value method is used in pavement design to determine the thickness of each layer of pavements. Can you hear me? Can you guys hear me?
Yes, we can.
Okay. So when designing, there are certain requirements needed for subgrade, subbase, and base. Basically, once you just know the thickness of our pavements. So we are using CBR value to calculate the thickness of our pavements. So for our subgrade, we need a minimum of 5% CBR value. For our subbase, we need a minimum of 30% CBR value. And for our base, we need a minimum of 80% CBR value, meaning that we can have more percentages of CBR value for the subgrade, subbase, and base. But these are the minimum requirements needed. That's what I stated. That's 5% for subgrade, 30% for subbase, and 80% for the base course. Do you guys get?
Yes.
Do you guys hear me? Okay. Most times when we're talking about pavement design, we have 4 layers. We have the subgrade. The subgrade is natural soil and determines a lot, because if natural soil is not strong enough, we most likely tend to use subbase. And if natural soil is strong enough, we might not use subbase. We just have our subgrade, base, and surface course. That's natural ground is good. That's subgrade is good. But if the subgrade is not good, we tend to use 4 layers. That's our subgrade, our subbase, our base course, and our surface course. So yes, we also have minimum thickness too. I think I should write this down. We have minimum thickness for each layer of our pavements. For our subgrade, it should not be, sorry, for our subbase, it should not be less than 150 millimeters. For our base, it should not be less than 150 millimeters. These are thickness of these layers now. And for our surface course, it should not be less than 40 millimeters, as recommended by the by specified something for Besha. So
Sorry, can you come again with that?
Okay, we have minimum thickness as according to CBR value standard for each pavement layers. Yeah, I'll send my notes to the group chat. So for our base, we should have a minimum thickness of 150 mm. Well, let's start from sub base. For our sub base, we should have a minimum of 150 mm when designing. That means if you get any value less than 150 mm, you should just adopt 150 mm. And if you have any value greater than 150 mm, it means that we are good to go. Then for our base, we should have a minimum thickness of 150 mm. And for our surface course, we should have a minimum thickness of 40 mm. This is according to CBR standards. You guys get me? I should come again.
You said sub-base, sub-base and base 150 mm, Abi?
Yes, and our surface course, minimum of 40 mm.
Okay.
Okay, now so let's now we also have traffic classifications. I don't know if Taiwo has sent the PDF, but there's a PDF showing the flexible pavement design curve graph. If you guys have it, you can open it.
The curve, I'm going to share the curve now. So
Okay,
you guys
so
can open it.
you guys can see it, then I'll just explain a few things.
I don't want to do street because I just like things.
Have you guys seen the curve?
That's in class.
You guys should check the group chat. I will send it to the group chat, so you can just use it to follow what I'm about to explain.
He has not sent it yet.
I'm on this, please. Just give me a minute.
I told my name is, I look at what I'm like, don't go and use your voice.
Okay, Taiwo has sent it. But you guys should open the flexible pavement curve. You can see different values for curve A, curve B, curve C, curve D, curve E, and curve F. We have number of cars available on the roadway when it's greater than 3 tons. For curve A, assume we have from 0 to 15 cars. That's the design for our CBR will fall in curve A. If we have 15 to 45
Sorry,
cars
is this not in
present on the road-
Akije's note?
Yes, in Akije's notes. You're right. If we have 15 to 45 cars on the road, that means we're going to calculate our CBR value using curve B. If we have 45 to 150 cars on the roadway, we're going to calculate our CBR value using curve C. If we have 150 to 450 cars on the roadway, we're going to calculate our CBR value using curve D. If we have 450 to 1,500 cars on the roadway, we're going to calculate our CBR value using curve E. And if we have 150 to 4,500 cars on the road, we are going to calculate our CBR value using curve F. Are you guys following? Does anybody have any questions to ask?
Yes,
Yes, we are following.
If you have from 0 to 15 cars, it means you're going to get our CBR value using curve A. There are 4 curves on that graph: curve A, curve B, curve C, curve D, curve E, and curve F. Curve F is the one with maximum number of cars on the roadway. For example, in Lagos, we usually have congested traffic. So that means when we want to calculate our CBR value to design our pavements on the road, we are going to use curve F to design our pavements. Do you get? And assuming you are from, maybe you're going to a very underdeveloped area, like, what can I say now? Maybe a village or something, where you just have 0 to 15 cars on the roadway. To design the CBR value, to design the pavement for that roadway, you're going to use curve A to get the CBR value. Do you get? Yes, the graph should be provided during exams. So after that, I think we should just take this question. Do you guys get me, or I should go back?
So please go back, please.
Please go back. Oh.
Please go back,
Okay.
I beg.
Look at your graph. Can you see your graph? You have a table that shows number of cars for each curve. For curve A, we have 0 to 15 cars. That means the traffic number of cars on the road, like normal, maybe due to average daily traffic, they estimated that number of cars on the road is always usually from 0 to 15 cars. So we want to design our CBR, we want to design our pavements. We're going to use curve A to get our CBR values on the graph. Do you get? Do you guys get?
Yes, we do.
The thing is that they'll be giving you,
Yes.
the number of cars in the question. So for example, they say 15 cars, there are 15 cars on lane A that's greater than 3 tons, whatever. You just go to your graph, look for where the number of cars falls. If you're giving 15 cars, that means it falls between 0 to 15, and that is curve A. So use our curve A on the CBR curve to get our thickness of our pavements. You guys get?
Yes, we
continue.
do. Yes, ma'am.
I think we should just solve a question. We solve a question, you'll probably be able to understand. So go to your lecture 2, page 16. I'm going to read out the question. You guys can jot, boys, in this thing, Adeboje's material. Page 16 of lecture 2, number 3. Are you guys with me? Or should I just read out the question?
Should you read out the question, just read out the question, and then, because the
Okay.
compiled material, I will share it after the tutorial when I
All right.
explain you.
Okay, I'll read out the question. A 2-lane dual carriage motorway is required to carry 4,000 vehicles per day, exceeding 3,000 kilograms. Hey guys, with me? A 2-lane dual carriageway motorway is required to carry 4,000 vehicles per day, exceeding 3,000 kilograms. Geotechnic tests show the CBR of the pavement materials as follows. Subgrade CBR is equal to 5%. Sub-base CBR is equal to 10%. And base CBR is equal to 80%. And the question now says, design the pavement using flexible pavement design curve or the Federal Ministry of Works. That's the pavement curve that you have with you. Do you guys get?
Yes, continue.
Okay, do you guys get the question?
Sorry, I sent a screenshot of the questions in group chat.
Okay, all right. So from here, the question given now, we have how many cars? We have 4,000 cars, right? So we go to our flexible design pavement curve. That's the curve that you are with. Then you now check the curve in which 4,000 cars fall. And that's going to be between 1,500 to 4,500. Are you guys with me?
Yes.
Okay, so it falls between 1,500 to 4,500. That's 4,000 cars, 4,000 vehicles on the road. And that's going to fall under what's curve F. Are you guys with me?
Yes, we are.
Yes. Yeah, we are.
Okay, so you go to your graph now and you look for, and sorry, just one more thing. There's a lane distribution factor you have to know for multi-lane road tables. I think someone should just screenshot this. I found this in APJ's notes. because Dr. Adewumi could not give us the table itself. So this is like a lane distribution factor that people use to just determine the number of cars. For single
What lecture
lane,
is
this is lecture 6. For a single lane, it's usually 100%. For 2 lanes, usually 100%. Then from 3 lanes and above, it's like 80%, basically. So just know that for single lane, the load factor or the lane distribution factor is 100%, and from 3 lanes and above, distribution factor is 80%. So do you guys get? So when you have 4,000 cars now.
Sorry, please, can you come again with that lane distribution factor? Sorry.
Okay, lane distribution factor has to do with number of lanes. For example, now, you have 1 lane and you have 4,000 cars on the lane, it's very easy for you to just say, this is 1 lane, we're going to have 4,000 by what? 100%, that is 1. When you convert it to like a whole number, that's 1. You're going to have like a normal 4,000 cars. But if you have 3 lanes now, it's like a standard lane distribution factor that I used to get number of cars that be available at that time. Normally, we're calculating based on each lane. You're going to probably do like 4,000 times, 4,000 times, let's say the lane has like 1,000 and you have 3 lanes. You're just going to do like 1,000, 1,000, 1,000. That gives us 3,000 for the 3 lanes. But if you're just having 3 lanes at once and you're giving 3,000, the estimated number of cars that will be on those 3 lanes and above, maybe 3 lanes, 4 lanes, 5 lanes, will be 0.8 times 3,000. Do you get?
Yes.
No.
Are you guys
Yes.
getting?
No,
So
I don't
single
get.
lanes
No,
and
I don't
double
get.
lanes. Okay, for single lanes or double lanes, whenever you're giving total number of cars, just multiply by 1. Then if you're giving like a 3 lane, 4 lane, 5 lanes, and you're giving total number of cars to be so and so, multiply by 0.8. Simple. Do you guys get?
Yes.
If you're
I'm
giving
sorry,
a
wait.
single,
No.
if you're giving number of cars for a single lane and a double lane, you multiply the number of cars by lane distribution factor of 1. And if you're giving total number of cars for a 3 lane, 4 lane, or 5 lane and above, you multiply by lane distribution factor of 0.8 to get the total number of vehicles per day. Do you guys get?
Okay. So if it's 2, 1 and 2 is 1. If it's higher than that,
yes,
0.8.
Exactly. So for single lane and double lane, you have what? Number of cars times 1. That'll give you a total number of vehicles per day. And if you're getting for 3 lane, 4 lane and above, that's multi-lanes from 3 lanes and above, you're going to multiply by 0.8 to get a total number of vehicles per day. So for the question given now, we are giving a 2-lane dual carriageway. You can see here that they said the traffic factor is what? 100%, but it's a 2-lane. So you're going to multiply, our lane distribution factor here is 100%, that's 1. We're going to multiply 1 by 4,000. And that'll give us what? 4,000 vehicles per day. Are you guys with me? Are you guys with me?
Yes.
Yeah.
Okay, so now you're getting what? 4,000 vehicles per day. When you get 4,000 vehicles per day, you now go to your graph. That's your flexible pavement curve. And 4,000 falls between 1,005 to 4,005. So we are going to use what's called F. Do you guys get?
Yes.
Do you guys get? So going to your curve now.
No, I'm sorry, I
curve
don't
F.
get. I'm going to use curve F. Like I can't see it from there.
Go to that PDF that I will send to the group chats that has the flexible pavement curve graph. Have you guys seen the PDF and the graph? Look at the graph. There are 6 curves there. Those curves represent number of vehicles per day. Those curves represent number of vehicles per day for number of lanes or whatever. You guys get?
Okay, thanks.
Exactly. So now we have 4,000 vehicles and it's a 2-lane road. So we're having 4,000 by multiplied by 1 to get 4,000 vehicles per day. And that will fall between what's curve F, because curve F has what 1,500 to 4,500 vehicles per day on a normal. That's like traffic condition of curve F. So now, looking at the question, we have a CBR value of 5%. Looking at the question, we have a CBR, subgrade CBR value of 5%. Are you guys with me? I don't have the
Yes.
physical curve here. So if we have a CBR value of 5% on curve F, we go to the graph and we look for 5% on the vertical axis. Are you guys there? I don't have the graph here, so I can't really show you guys. But once you guys look at the graph, go to 5% on vertical axis, then trace that 5% to curve F. Are you guys there? Then you now bring it down to the horizontal axis to get number of inches. That's the thickness of the subgrade.
Yeah.
That will give us something like what I'll give
15.
us
19
No.
inches.
exactly, that's like 19 inches rather.
Yeah.
In my note, I have 19.2 inches.
19 is 19.
It's 19, it's
Okay.
exactly 19.
Okay, exactly 19.
19.1,
Fine,
is
that's
it
right.
19.
Okay, we can use 19 inches.
Yeah.
Fine, that's very fine. So let's see. So now that's the thickness of our subgrade is what? 19 inches. Converting to millimeters, we multiply by there is going to the standard of 25 mm, meaning that what 1 inch is equals to what 25 mm. Multiply 19 by 25 mm. What's that going to give us?
$475.
Okay, so
mm.
that's our thickness of our subgrade is what? 475 mm or what? 19 inches. That's what CBR for subgrade. Now we are going to go to subbase. We have a CBR of what? 10%. We go to the vertical axis. Look for
I'm sorry, I have a
10% there.
question, please.
Abeg,
Yeah, what
please,
question
small
do you have?
How'd you get that 45? Where did you get 45 from? 19 times 45.
No, I didn't say 45. I said
25.
25. 1 inch. You're converting to millimeters. Do you
Oh,
get?
okay.
So 1 inch is
Okay.
equals to 25 millimeters.
25
Now that we have
okay,
19 inches, we multiply by 25 to give us 475 millimeters. Do you get?
okay. Yeah, thanks.
Yeah, so now for the sub-base CBR, we're going towards 10% on the vertical axis. If you go there and trace it to curve F, we're going to get, what do we get again? About 12.8 inches.
12.8.
Yeah, that's about 12.8 inches. Did any other person get it? Apart from Sheung.
Same here.
Got 12.8 inches, right? Okay,
Yeah.
now so we're going to convert to millimeters. That'll be what? 12.8 times what? 25 millimeters.
It's 320.
Exactly, that's going to give us
320.
320 millimeters. Yes. Now for our base is what? 80%, right?
Yeah.
So we go to 80% on the vertical axis and trace it to curve F. That will give us something like 3.5 or 3.6. If anyone does not understand, please let me know.
Shay, please, I think you should slow down a little because they're like a little bit fast.
Okay.
She's very fast. I'm even lost. Now.
Okay, what part are you lost at? Maiwa, what part are you lost at?
Getting the thickness. The
Okay, the
thickness of the
thickness.
subgrade. Yes.
Shay,
Subgrade.
sorry to interrupt your class. It's Taiwo. Do you mind? I think after you've gotten those 475, can you just be interpreting it in the diagram? So it will be
Okay,
you get so
I
you
want us
just
to get the value first before we get diagram, sir.
I get your point, but since they are saying probably it may be too clumsy. I don't know, just a
Okay,
suggestion.
so we're actually meant to draw a diagram first of all, and it's meant to look like this. Can you guys see this diagram in my notes? You can draw it, then we can get our values and put it inside. So let's just draw this diagram first. Where we have our subgrade, we have our subbase, we have our base course, and we have our surface course. You guys are done, let me know. Sorry for being too fast.
Yeah, I'm done.
Is everybody
Why
done
not
drawing
done?
it?
No.
I'm not done. No, come, chill.
Done.
Is everybody done?
Done.
Please, let me place it well. I can't see.
Okay, sorry. Can you guys see now?
Samson.
No.
We can just screenshot it now. No need to save time.
Okay. So from this diagram, you can see that we have our subgrade. Our subgrade is a natural ground. Then we have our subbase here. After our subbase, we have our base course. And we have our what? Surface course, right? And the CBR value of subgrade is what? 5%. CBR value of subgrade is what? 5%, right?
Yeah,
I guys
yeah.
see me?
Yes, we are.
Yes.
Go to the vertical axis or the flexible pavement design curve and trace it to curve F. I think that gave us 19 inches. Right?
Yes.
Yes,
So
you did.
this
Yes.
this our 19 inches now is going to span from here. This top here, this 19 inches is going to go from here, like the top of the pavement to the top of the subgrade. Do you get? So that's from the top of the subgrade to the top of the pavement. That's the whole thickness of the pavement.
Why?
That's going to give us 19 inches. And that's also
Why?
what? 475 mm.
Why?
Because this curve here is used to determine the thickness of our pavements. That's what this curve is used for.
So
Do you
we're
guys
not determining the thickness of the subgrade.
No, we're not determining the thickness of the subgrade. The thickness of the subgrade is used to determine the whole pavement layer. The subgrade is the natural ground. It's like it's what you cannot see. It's underground, like foundation. You guys get?
Okay, thank
Like
you.
normal, they'll test for foundation, test for a certain level after it. I'm just trying, it's not like it's foundation, but imagine it's actually something you cannot see. And what's the visible layers are the thickness of the pavement actually covers from the surface course to the sub base. If you notice, we're not giving a CBR value for surface course, because you can get it from the CBR value of base course. You get the thickness of surface course from CBR value of the base course. Let's just continue, you understand?
Seyi, sorry, question.
Yes.
So what you are saying is the thickness of the subgrade we got using the graph is from the top of the subgrade to the top
to the
of the
pavement.
surface.
Yes.
Okay.
It's basically the thickness above the subgrade.
Exactly. Thickness above the subgrade to the surface of the surface course, to the surface, this part here, to this part. This is our subgrade CBR thickness.
Yeah, like the
that we
thickness
get
of
from
the
the graph.
pavement.
Yes, thickness of the pavement. Then for our base course, for our sub base, we have what? CBR of what? 10%. If we go to the graph, 10% on the vertical axis and trace it to curve F, we are going to have a value of 12.8 inches.
Yes.
Can you hear me?
Yes,
so that
we can.
12.8
Yes, I
inches
can.
is going to go from the surface of the sub base to the pavement surface. Do you guys get?
Yes.
So that means our CBR value of sub base is going from the top of this sub base to the pavement surface. And that's giving us 12.8 inches, which is equal to 320 millimeters.
320 mm.
Is everybody with me?
Yeah.
Yes, ma'am.
Then also after that, we have a base course CBR value of 80%. We will go to the vertical axis of 80% and trace it to curve F. That's 80% on the vertical axis. Trace it to curve F to get our pavement thickness. That's going to give us something like 3.5 inches.
Yes.
Has any other person done it? 3.5 inches, right? So that will not be from the top of the base course to the top of the pavement. Do you get? From here to here.
Sorry, where to where?
This 3.5 we've gotten now is going to be from the top of this base course to the top of our surface course. Not be 3.5. Do you get? So now we've gotten thickness from the subgrade to the pavement surface, from the sub base to the pavement surface, and from the base course to the pavement surface. Do you guys get? So just note that from the subgrade surface to the pavement surface is going to give us our what? it's going to give us 19 inches. And from the surface of the surface base, sorry, from the surface of the sub base, the surface cost is going to give us 12.8 inches. And from the surface of the base course to the what pavement surface, which was 3.5 inches. Are you guys with me?
Yes.
Yes.
No, recall that I actually made some minimum requirements. Remember at the beginning, I stated that for sub base, the minimum thickness should be what? 150 mm. Remember, for base course, minimum thickness should be what? 150 mm. And for what surface course, the minimum thickness should be what? 40 mm. That's according to what standard. Can you guys remember?
Yes.
Yes.
So now we're going to calculate each of the pavement
Please
layers.
come again with those minimum requirements, please.
At the beginning, I said that minimum requirement for sub base is what? 150 mm thickness.
Hello,
That
Seyi,
means
I
your
can't hear
sub base
you.
must not be. Minimum thickness for sub base must be what? 150 mm. Meaning that we must not have a sub base design less than what? 150 mm. If we calculate our sub base and we have something like 148 mm, we must go with what? 150 mm because that's the minimum requirement. But if we calculate for our sub base and we have a value of, let's say, 200 mm, there's no need to use 150 mm because it is what above the what's requirement. That means it's actually what's correct. Do you get?
Yeah.
So now looking at this diagram, we want to calculate our sub base. Our sub base is going to give us what? The distance from the beginning of the subgrade to the pavement surface to the distance from the what? Sub base surface to the what? Pavement surface. Can you guys see my hand? To calculate this thickness here. Let me do this one now. Calculate this thickness here. We are going to have what? Distance from here to here minus what? Distance from what? Here to here.
Okay.
That's like normal mathematics. Same for our base. Let's calculate our base. We're going to have that's our base cost thickness is actually going to be from here to here. So it's what's our base cost thickness. And that's going to be from what? Distance from here to here to the what? This thickness. Are you guys with me?
Yes.
Okay, now so let's calculate for our sub base. Our sub base now will be what? 19 inches.
6.2.
Exactly. That will be what? 6.2 inches. 19 inches minus what? 12.8 will give us what? This sub base what? Distance
6.2 inches.
or this thickness. So we now convert to what? Millimeters. That will give us how many millimeters? 6.2 times 25. That will give us 155 millimeters.
155.
155 millimeters is better than what? 150 millimeters, right? That means we are what? We are on track. It's within the design requirements. I mean, it satisfies the design requirements. Are you guys with me?
Yes.
So now thickness of our base is going to be what? This distance from here to here. Exactly. 12.8 minus what? 3.5. That's going to give us what? 9.3 inches.
9.3 inches.
Multiplied by 25, convert to what? Millimeters. That's going to give us
232.5.
232.5 millimeters. So that's going to be, that's what? Better than 150 mm. That means you are what? That means satisfies design requirements.
Yes, it does.
Are you guys with me? If you don't understand, let me know, please.
Please come again for that base.
For the base, you're going to have what? From this surface here, that's from surface of the sub base to this pavement surface. Can you see?
Yeah, I can
minus
see it. Go on.
The surface of the base to the what? Pavement surface.
Okay.
So that's going to give us what? 12.8 inches minus what we got at the beginning. We got 3.5 inches for our thickness of surface.
Okay.
So that'll be what? 12.8 minus what? 3.5. And that'll give us what? 9.3, right?
9.3
inches. Exactly. Now convert to millimeters times 25. That'll give us what? 232.5 millimeters, right?
Yes. 232.5 millimeters.
Yes. This is what? It's better than what? 150 millimeters, which is the minimum requirement for what? Base cost. That means that what? Our design is what? Satisfactory. Do you guys get?
Yes.
If you don't understand, let me know.
We get it now.
Okay. Now for our surface cost is very easy. We've already been given the distance here. This is our surface cost. Our thickness of our surface cost is from here to here. Can you guys see? From this top of the pavement to the top of the base. That's our distance of what? Surface course. And we got it to be what? 3.5 inches. So there's only to calculate that one. So now we multiply by what? 25 millimeters. It's convert to millimeters, and that will give us 3.5 times 25 millimeters. That will give us 87.5 millimeters. Are you guys with me?
Yeah.
Yes.
Do you all get 87.5 millimeters?
10.5 millimeters, yes.
Yes. And that is what? That's greater than 40 millimeters. Meaning that what? Our design is what? Satisfactory. Because the minimum thickness for our surface course should be what? 40 mm.
Okay.
Are you guys with me? So now there's a rule that states that for we round this thing in inches, we round up to the what? Nearest what? 0.5 inches. And for what? Millimeters, you round up to the what? Nearest what? 5 millimeters.
Come
You guys
again.
get that? When we have our thickness values in inches, we round up to the what? Nearest 0.5 inches. And we have our value in millimeters, we round up to the what? Nearest 5 millimeters. Are you guys with me?
Yeah.
So now you can see that I think for what do we have for our sub base? Our sub base thickness is what again? Can you guys hear me? No,
6.2
our
inches.
sub base thickness is what? 6.2 inches, and that was how many millimeters?
155 mm.
155 mm.
For our sub base, Abi. So 155 mm,
Yeah.
that's like nearest 5 mm. That's okay. 155 mm. But for our inches, we have what? 6.2, right? We round up to the nearest 0.5. So we'll be using what? That means if we are leaving our value in inches, we're going to be using 6.5 inches, nearest 0.5 inches. And if it's going to be in millimeters, we're going to be having what? 155 millimeters. Do you guys get that?
No, Seyi, no. I didn't get
When we
that.
have our
Wait, sorry.
Yes.
Sorry, I have a question. Oh.
So we don't have
Okay.
to put our answers in inches and millimeters. We just have to pick one.
Yeah, you can pick one, any one you are picking. But if you're picking your answer in inches, you have to round up to the nearest 0.5 inches.
Okay.
So do you round up after the table or before? Because that's
After you've
kind of
gotten your
confusing.
after you've gotten your total, after you've gotten your final value. Our value for our
So-
subgrade was 6.2, right?
Yes.
Yes.
So we round up now to 0.5. That'll give us 6.5 inches.
Okay.
So you round higher.
I don't know.
Yes.
Are you rounding? Are you supposed to take it back? Since it's 6.2, it's not.
No.
No, you have to when you're designing, you have to provide for extra miscellaneous whatever.
Okay. So
Do you guys
my
get?
question is now, so if we do this,
Okay.
can you hear me? If we do this
Yes, I can hear
6.5,
you.
that means we'll do 9.5 too.
9.5 for which one?
For the one that is 9.3.
Yes. You're
By the
rounding
end
up
of
to
the
the nearest
day,
0.5.
our total will not be 19 again, and that's okay.
Yes, no, when you're getting your final values, you've gotten your total
Okay.
depth is 19. Now you're now getting for what? Each thickness of you're getting for each thickness of each layer's thickness. This is what we're concerned about now, each layer's thickness. When we've gotten all our values for each layer's thickness, we now round up to the nearest whatever, if we are using inches or millimeters. Do you guys get? Is anybody confused?
All right. Thank you.
Seyi,
So
one
then-
last question, so that we just
Okay.
Oh, yeah.
All right. I'm
Okay,
listening.
said we have 6.2 and we round up to 6.5.
Yes.
Is it that 6.5? If we now want to calculate with millimeters, is it the 6.5 will convert, or the 6.2, then round that 6.2's qualified millimeter to the nearest 5 millimeter?
The 6.2 you call it is 6.2 that you convert to millimeters, because that's your initial answer. 6.2 inches your initial answer, right? We convert to millimeters. I don't know let's see what we get. If you get 6.2 inches in millimeters.
But if you have 6.5 and you multiply by 25, your answer will still be 5. Either way.
6.2 is going to give us 155 millimeters. And that is already okay. It's the nearest 155 millimeters for our millimeter conversion. But if we have it in inches and it's 6.2, we have to round out 6.2 to the nearest 0.5 inches. Would you get? So that means if our answer is in inches, we're going to have 6.5 inches. And if our answer is going to be in meters, we're going to have 155 millimeters.
Hey,
Okay.
Sarandu, you are not doing any further computation,
are,
right? Like
are
you
you
only think of that conversion at the end of your solution, like after you've solved. So if you are sticking with inches, go with your inches. So I understand that there may be a conflict, but you are not doing anything again. That's your final position. So that's what she is trying to say, sis.
but if I'm converting from inches to millimeter, I'll still have
Yes.
my inches answer now. Like that 6.2 will still be there now.
Yes, this will be there, but
I'll just
converting
leave
to
it
millimeter.
now. Since I'm sticking with millimeter, I'll just convert to the
Yes.
nearest 5 millimeter.
Yes.
Okay. Thank you.
Yeah, so what's our, sorry, what do we get for our distance for our
Question.
base?
I have a question. Sorry.
Okay.
So are we leaving that 6.2 there, or are we going to do approximately 6.5 in front, or you completely remove the 6.2 and put the 6.5?
See, I think to be very safe, we should just round up. We should just do both of them. If you're already calculating in inches and converting to millimeters, just leave your answer in 6.5. That's nearest 0.5 inches. And leave your answer in 155 millimeters, which is nearest 5 millimeters.
No, that's not what I'm saying. I'm saying, are we going to, we already calculated when we had 6.2 first. So I'm saying, are we removing the 6.2 and replacing with 6.5, or we're saying 6.2 inches, which is approximately 6.5, so that we can know that we got the correct answer. We're just rounding up.
You also let me you're rounding up. You get 6.2, you leave
So
it there. And now say,
approximately.
yes, that is 6 point. That will not be equal to 6.5 inches. Round up to the nearest
Okay,
0.5 inches. You guys get?
Yeah, hello, Seyi.
Yes.
So,
what question do you have? Okay.
Now we are changing 6.2 to 6.5, Abi. We are rounding up.
Yes. Nearest 0.5 inches.
Okay, if we do this same thing for the other two, if
For
we
the other
add,
two,
yes, the base and the surface. So if we add it together, I think it will be higher than the 19 inches, which is the total.
Yes, to be higher.
Which one I would use?
The thing is that you already have your whole pavement thickness to be 19 inches. The most important thing is to see the thickness of each layer that you're going to use. So obviously, after just like saying, let's say now, for example, our required thickness is 19 inches. But the thickness that we are going to provide is going to be some of the surface course, the base course, and the sub base. You can remember concrete design. Can you remember? Can you relate what I'm saying to you?
Yes,
We have
I guess.
our required. Our required is 19.
19.
So that we are going to provide is going to be higher than 19, which will be
19.
some of the sub base, base, and surface, taking into consideration the rounding off for inches and millimeters.
Okay, thank you.
Do you understand now? Okay,
Yes.
now for our base, what was our thickness for base? Sorry, I was not calculating.
9.3.
9.3. So converting now to inches, that's going to be 9.5 inches, right? Let me just write it down. Our sub base is 6.5. This is 9. This will be 9.5. That will be 9.5 inches, converting to 0.5 inches. Now that 9.3 times 25 is going to give us 232.5 millimeters. So we now round that up now to 233. I'll be 235. You guys get that?
Yeah.
Yes.
Can we see
So
how your final solution looks, like your final diagram when you solved it?
When I solved it, this is supposed to look. I'm not even solved it complete. This is the one that Dr. Adeboje drew.
Yeah, she
but after solving,
I beg.
So now we have our sub base to be our base to be 9.3 inches. Rounding up to 0.5 inches, we're going to have 9.5. Then we multiply that 9.3 and change it to millimeters. We're going to have 332. But rounding up now to 5 millimeters, nearest 5 millimeters, we're going to have 335 millimeters for our base. Do you get that?
Yes.
Yeah, we do.
Now, our thickness of our surface course is 3.5 inches. That is okay because it's 3.5 inches. But we multiply 3.5 inches now times 25. That's going to give us 7.5 inches, right? I'm sorry, it's 7.5 millimeters, right? Rounding up now to the nearest 5 millimeters, let's give us what? 90 millimeters.
90
as per
or
5,
88.
10. Yes. No, we're not the nearest 5
5.
millimeters.
Not
Nearest
5.
5 millimeters. 5 millimeters as per 5, 10, 15. So if you have any number between 0 to 5, you always was pick 5. If you have a number between 5 to 8, you pick 10. If you have a number between 30 to 35, you pick 35.
So
I mean, any number between 31 to 35, pick 35. Yes.
Sorry. For the sub base.
Yes, sub base.
Yeah, we got 155 millimeters, right?
Yes.
Okay, so does it mean we're going to round up to 160 for
No need to round up to anything because it is what 155 millimeters, and that's already nearest 5 millimeters. Like you don't
But
get.
that's only if you're leaving it in mm, right?
Yeah, that's if you're leaving it in mm.
Because you still have to fix your 6.2. Because
okay.
I should just write. Let me just write. For our sub base, we had 6.5 inches or 155 mm. For our base, we had what's our base again? 9.5 inches or we had 235 mm. That's after what? Conversion. Then for our base, we have what? 3.5 inches or we have what? 90 mm. You get? So if we add, our final answer now should be what? 6.5 plus 9.5 plus 3.5. That means our thickness should be 19.5, which is correct because it's still in nearest rounded. That means our required thickness of the pavement is 19 inches. For the thickness which we are going to provide, taking into consideration all the rounding up, that's just according to standard, it's going to be 19.5. You guys get?
Yes.
If you have any question, please ask. We are going to second question now.
let's move on.
Sorry, still on that rounding up issue, Seyi.
Okay.
Let's say, for example, you get something like 156 mm. Are you going to round up to 160 mm? Is that what you're saying?
Exactly. Yes, 160 mm.
And
Nearest
if you
5
have
mm.
152, you'll go to 155.
Exactly, 155 mm. Yes.
Thank you.
So second question now says, assuming, it's in my notes, but I don't know if you guys will see my handwriting. Let me just read it out. Assuming an average of 3 lanes in each direction with a factor of 0.8. Have you guys written that down? Should I continue?
Do we have a sample of that question?
It's not in our material. This is just what's stated. It's not in our material.
Oh, okay.
It's not in our material.
Okay, you have
so
to take
assuming
it slowly
an
then.
average,
Go on.
okay. Assuming an average of 3 lanes. Assuming an average of 3 lanes in each direction with a factor of 0.8. In each direction with a factor of 0.8. Are you guys there?
Yes.
Design a suitable pavement structure for the highway. Design a suitable pavement structure for the highway. Using the Federal Ministry of Works and Housing CBR method. Using the Federal Ministry of Works and Housing CBR method. For a total of 2,455 vehicles.
Wait, slow down.
Let me take it again. Assuming an average of 3 lanes in each direction with a factor of 0.8. Full stop. Design a suitable pavement structure for the highway using the Federal Ministry of Works and Housing CBR method. Are you guys there?
Yes.
For a total of 2,455 vehicles. For a total of 455 vehicles.
Okay.
Exceeding 3 tons. Where are you? Is anybody
So
lost?
for a total of what?
For a total of
For a total of what?
2,455 vehicles. Are you there?
Yes.
Exceeding 3 tons and growth rate of 5% per year. Exceeding 3 tons, TONNES, and growth rate of 5% per year. And design period of 10 years. Let me take it again from the top. Assuming an average of 3 lanes on each direction with a factor of 0.8, full stop. Design a suitable pavement structure for the highway using the Federal Ministry of Works and Housing CBR method for a total of 2,455 vehicles, exceeding 3 tons, and growth rate of 5% per year, and design period of 10 years. Do you guys get that?
Yes.
Do you guys get that? Because the question is on our material. This is from Budget Direct. Okay, now, assumptions. Assume CBR or subgrade is equal to 5%. Are we reading that? Assume CBR or subgrade is equal to 5%.
Is equal to what?
5%. 5, F-I-V-E. Are we there?
Go on.
Assume CBR value of assume CBR of sub base equals to 10%. Are we there?
Yes.
And assume CBR value of base cost to be equal to 80%.
Okay.
So now I need you guys to take down this formula. F is equal to P into brackets 1 plus R raised by N. See my notes. Are you writing down the formula?
Yes.
F is equals to P into 1 plus R, all brackets raised by N. Where what? F is equal to future traffic. Are you guys there? F is equals to future traffic. P is equals to what? Present traffic or number of vehicles per day greater than 3 tons. Are you guys there? Man writing this balance and reading it out. P is equals to present traffic or number of vehicles per day greater than 3 tons. R is equals to growth rates. N is equals to what? Design period or what? Number of years. Let me know when you guys are done, please.
Yeah, I'm done.
Are you guys done? So now, what from this question? Yes, I'm listening.
So I want to take you back for that question that we just solved from the material.
Yes.
They stated 3,000 kilogram. We're not using it for anything, right?
If you check your flexible pavement curve, whatever is there, like that 3,000 kilograms taken as 3 tons, exactly what Sean said.
Mm-hmm.
So you see there, you see number of vehicles per day greater than 3 tons on a lane, something. Is that your flexible pavement design curve? Can you see? So from this question now, we are looking for what? We're looking for what? Future traffic. We have our present traffic to be equal to what? 2,455 vehicles per exceeding 3 tons. We have a growth rate R of what? 5% per year. And we have design period N of what? 10 years. So now we have to find what? Find our future traffic. Imputing our values, P is equals to 2,455 equal to what? 1 plus R. Converting R to over 100. That was give us 0.05. And now N is what? 10 years. Are you guys following? Like it's here already. That was give us 2,455 into brackets what? 1.05 raised per 10. That will give us number of vehicles.
1 plus was 0.05, I mean?
Yes, raised per 10. Converting your 5% to 5 over 100.
Okay. 1.05.
That give us 2,455 into brackets was 1.05 raised per was 10. That's giving us 399
3,999.
Yes. So we round up to 4,000 vehicles. You just round up to 4,000 vehicles to make it like a good number. I mean, all these things are estimations. So now, if you go back to our question, it says, assuming an average lane in an average of 3 lanes in each direction. Average of 3 lanes in each direction, meaning that was the total of what 6 lanes. That means a 3-lane dual carriageway. And we already will be given our factor. Our factor of lane distribution factor is what 0.8.
I'm sorry, I have a question. Sorry.
Okay.
You said assuming a given average of 3 lanes, then say something like 6 lanes. How did you get the 6? I didn't get you.
3 lanes in each direction. 3 lanes in each direction, meaning that what is a 3-lane dual carriageway. A total of 6 lanes.
Okay, yeah.
If you go to this CEG530 table, let me show you. Go to this CEG530 table, this is the lane distribution factor. We have what? Lane number 3. And we have a number of lanes in both directions. That's total number of lanes. This is a what? This is 3 lanes in both directions. Meaning that we are going to have 6 lanes. So if we come here now, that's going to give us what? 6 lanes. We always have 6 lanes in both directions. Sorry. Hi guys, can you guys see now? We have what? 3 lanes in both directions. Meaning that what? Total number of lanes in both directions is what? 6.
Okay.
And we come to what? Lane number 3. That's going to give us what? 80% over 100 to give us what? 0.8. They won't give us in the question, so there's actually no need to stress. I'm just showing you guys. They're giving us in the question here. Direction with a lane distribution factor was 0.8. Are you guys with me?
Yeah.
Yes, ma'am.
Okay, so now we have our future vehicles. Our future number of vehicles calculated is what? 4,000 vehicles per day. This should be 4,000 vehicles per day. Now multiply that 4,000 vehicles times the what? Lane distribution factor of what? 0.8. That'll give us what? 3,200. Are you guys with me?
Yeah.
Who doesn't understand? So that means our estimated future traffic is going to be what? 3,200 vehicles per day. If it was 2 lane, it was just a 2 lane, the factor will have been what? If it was either a 1 lane or 2 lane, the factor will have been what? 1.0. But because it's actually what? This is a 3 lane. That's why we're having the factors be what? 0.8. Because from 3 lane and above, the factor is what? 0.8. Then anything less than 3 lanes, the factor is going to be what? 1.0. So assuming the question was saying maybe 1 lane or 2 lane, our future traffic vehicles will be what? 4,000. But because it's actually for a 3 lane, that's why we're having our 4,000 times 0.8 give us 3,200 vehicles per day. So am I talking too fast?
No, ma'am.
Okay, you guys are following. So now our total number of vehicles per day is 3,200. We now go to our pavement design curve graph and check number of vehicles allocated to each curve. That will fall under what curve?
Curve F.
Curve F.
I thought it was curve A.
Yeah?
Are we
That's
sure it's
supposed to
curve
be a
F?
joke.
Is it not curve F?
Okay, yeah,
It's
the answer is curve F.
Are you trying to do dry jokes right now?
So if you can observe, so I'll not waste anybody's time. You can go and read our books. You can observe what we did the last time is what we are going to do again. Like for our subgrade, our subbase, our base, and our surface. And we have the same values of our CBR grades as the last one. So now for our subgrade, we have 5%. We come to that curve, check the 5% on the vertical axis, and trace it to curve F, and bring it down the horizontal axis, then we get our thickness value for our subgrades. That's exactly what we've done before. Do you want us to resolve everything, or we should just stop here?
No need, Joe.
No need.
Exactly. So it's the same procedure from what we saw the last time. You can now bring it in here. The most important thing is how to get our number of vehicles per day. And since it's 3 lane, we are going to multiply our future number of vehicles times 0.8. Is there anybody that has any question?
Sorry, this question is at Taiwo. Please, when are we getting the video on YouTube?
This guy is not even done, sir. We've not spoken about AOC.
Taiwo, I think it's time for Taiwo to, if anybody doesn't have any question, I think it's time for Taiwo to come in with the AOC.
Okay, quick question. I have a question before
question?
AOC.
Okay.
Please, are these the only calculations that can come out in this exam? Because I'm seeing other things in the material. But you know, calm down now. Calm down.
Calm down now. Taiwo, be calming down now.
But he didn't solve the questions in the material. That's why I'm asking. Because it seems like we're done with calculations now.
We are done with calculation. You only gave us one question in the material to solve. And that's the lecture 2, page 16, number 3. And this other question just stated for you.
No, but there's other ones. That's what I'm saying. There's other questions. But the solution is not there.
That will come with the AOC,
thank you,
so
ma.
you understand from there. All right, then.
Thank you so much, ma.
Moving over to Taiwo now.
Thank you, Seyi.
Sorry, are we done with the calculation like this?
Yes. The remaining calculation is what we've done before.
What do you do before?
What we calculate, how we calculated our subgrade, base cost, the same thing, because the same CBR values.
Another day,
no, the same thing.
Okay.
I think that's fair.
Thank you.
Sounds like clear.
Yeah, I'm clear.
Hey, right. Talk to my man.
Hello.
It is well. Seyi, thank you so much. God bless.
Yeah, welcome.
Thanks, Seyi.
For those that probably be reading CEG530 since, then you must have completed your syllabus. So I'm going to be sharing my screen. Each lecture, I'm going to be going through on what you are expected to focus on. But to start with, for lecture, as earlier intimated, that lecture 1 and 3 will cover for tests, and lecture 4 for exams. Now, but we've been able to confirm that the test is going to be OBJ, completely OBJ. And then he said that we don't really have much to do.
Thank you.
All you have to do is just skim through. And I also confirmed that the
OBJ.
Taiwo,
lecture 1 and 3 is for test.
Yes, I'm going to share my screen very soon, and I'm going to show you all you need to bother. So that lecture 3 you have, any material you have with you, just discard it. After this story, I'm going to send the lecture 1 to 4. The defined lecture 1 to 4. So basically, the OBJ, once again, no German question is going to come out. Well, we confirm that with him, and then you don't really need to do much. Probably you want to read it maybe once or twice, like storybook. I think that should be sufficient. It's going to be maximum of 30 minutes test, but he's suggesting maybe it's going to be 15 minutes, and exam will be probably 2 hours or thereabout. Let me share my screen now, and then I'm going to open each lecture and the area to focus on. All right, so this is lecture 1. Everything in lecture 1, basically from page 1 to 12, you are expected to just skim through for tests for lecture 1. Now, for lecture 3 with you guys is very much. Lecture 3 with you guys is very much.
Please, I'm coming. Please, can you calm down so much, my big?
That was so much more.
For lecture 1, everything in lecture 1, you are expected to skim through for tests. Just skim everything in lecture 1 for test. Guys, don't try to probably think too much about it. Just skim through, understanding every subheadings, and then for lecture 3, he said calculation about kini Seyi.
Seyi didn't calculate in the
calculation, okay. Just skim through, based on what he said, but then if you know you want to read it,
lecture 1.
You know you are Seyi, be clear.
For lecture 3 too.
The
lecture 3 with you guys.
But I like stuff now.
The lecture 3 with you guys is about maybe 60-something pages or so. So please discard that one. Been able to compress it together with him to just 40 pages. So apparently, what was with you guys before? All you needed was just page 1 to 11 and also another page 1 to 3. But this is just a compilation. So I think it's easier this way. So you don't need to go back to that material. I'm going to share this for material again to Civil Files Group. So all you need, just skim through lecture 1 from page 1 to 14, as opposed to the 60-something pages before. So that is basically for test.
I want to say I love you, Taiwo, but
Then
thank you.
God bless you.
Hey, Seun Alpha.
Now, for exam, please listen attentively for exam. Now, exam is going to be 6 questions.
Wow.
It's going to be 6 questions, answer 4. Now, one question will be on pavement design. Basically, no calculation under it. One question will be on pavement design, and what you are expected to, one full question will be from page 1 to 7 of this material, this lecture 2 material. Page 1 to 7 of this material, a full question will come out on it, according to Dr. Adeboje. So you have to focus on page 1 to 7 for a full question. The CBR that Seyi just explained. Now, if you check this lecture 2, engineering aspects, so page 1 to 7 will cover one question. You have to focus on that. I don't think any other. Okay, another thing in this material, this estimation of traffic, cumulative ASU load. Yes, cumulative ASU load will cover one question also, one full question also. So cumulative ASU load will cover one full question, as stated by him, and it's under cumulative ASU load that you have. I think now from this Bosniak elastic theory, please don't touch it at all. Bosniak elastic theory, you are not expected to read anything here. It's not going to come out. He said he's not touching it because this have a lot of moving or something like that. So you are not expected to like touch this. So he's not bringing anything out here under this Bosniak, what's this thing called? This Bosniak theory. So you're not expected to touch anything here. But this cumulative ASU load, please, cumulative ASU load, this work example on cumulative ASU load, please go through it. Please go through it. The work example.
Wait, so that's calculation that we need to know.
Calculation.
It's not calculation.
No. Still the calculation
is not calculation.
Wait, calm down, Bamishe. Let me this calculation. I want to confirm if it's under that box next something.
It should be.
It should be under it, Abby. I think it's under it. Yeah. It's under that box next something. So this diagram, let me just confirm. Because he said everything under that book, so we should not bother ourselves.
But cumulative ASU load, is it theoretical or calculation? That's what I was asking.
For the cumulative ASU load, although he told me earlier that cumulative ASU load will carry one question. Let me confirm this with him. If the calculation
probably is not that, it doesn't even look that difficult. It feels like we can run it.
Yeah, but that business is the one he said we should not bother ourselves. So this material basically focus page 1 to 7 for one question. Cumulative ASU load will carry one question, right? Cumulative ASU load will carry one question. Do not read Bosniak. Then the CBR that Seyi just explained. Please read the theory on CBR. All this theory, like, okay, how many percent will be for this particular, all those percentage, 0.8, 100%. Please just try to know them. It's compulsory. It's a compulsory question for everyone. That CBR Seyi just explained. So that is a compulsory question coming out live and direct. So that is basically all you have to like focus on lecture 2.
Is that one entire question?
CBI is a full question, a compulsory question. It's going to have some theory explaining the basic concept of your understanding, and then the calculation will come out. For lecture 4. Now, initially, he had it in mind to, lecture 4 is basically covered. So basically, he had it in mind to probably bring out theory and calculation, but thanks to Seyi, Omoni, Tutor, and then myself, were able to convince him that the calculation looks quite much. So cover's question will only cover theory, no calculation that cover. So it's better to read cover, but do not read any calculation. Just read the theory aspect. No calculation is coming out on that. So this is just 7 pages. So this lecture 4, this 7 pages is carrying a whole question, excluding the calculation. I don't know if that makes sense. So basically, lecture 2 is carrying about 3 questions already. Cumulative ASU load. You said what?
Yes, I'm with you.
Yeah, so lecture 2 is carrying about 3 questions already. While lecture 4 is covering is going to cover and cover it. So you are expected to answer 4 out of 6 questions. So he gave us these 4. They are sure banker. However, he now shared a PQ, but that one he just said this might help that we can look through it or not. But most likely, I feel like he's just going to repeat this, probably just change, So basically, this is the past question. He shared this yesterday night, so. I'm going to send this. I think the first one is the CBR, which is going to be compulsory. Like answer question 1 and then that 3 question.
Did he take this course before?
Give a CC account of 2 form of. So this form page 1 to 7. I said if we get page 1 to 7, just send it. Can you hear me?
Yes.
We can hear you.
All right, so he took this course before. So he shared this one yesterday night. So question 1 and 2 already cover CBR and the page 1 to 7. Then discuss the method of increasing subgrade by comparison. Like I said, I told you guys, it's going to be 6 questions, answer 4. And he has told us what to read. So I don't know whether this subgrade is under the pavement. I've not read the material, but I hope he's going to cover that. So just
we are sending this one to us too, are we?
Yes, now I'm
Do
sending
you see that
everything.
it's 2019, 2020 that is on top of this thing, right?
And now, 2019, 2020. First semester, yes. So apparently what happened was that some people had carried over first semester. So this was the exam. So some people had carried over this course, but was able to put some string for them so that CITS can bring it for them to register first semester. So he conducted a personal exam for them. So this was the exam they gave them. So you guys, so automatically you should know our exam will be very similar to something like this. So
understood.
I guess that's pretty much it for CEG530. Yeah.
Thank you so much, Taiwo.
And also, I'm going to share the graph. Okay, Toby Joe.
Yeah, you said the first question will be on pavement design, page 1 to 7.
No,
yeah?
CBR is the composite question. No. I just said that
the
whole question will come out under pavement design. When page 1 to 7 will cover a whole question. Yeah.
So
but he only gave us 4 out of 6.
It's separate from, but they are in the same material.
Taiwo.
Okay.
Taiwo.
All right. Thank you very much.
Yeah. Hello, sir.
Taiwo, I'm sorry, but for clarity's sake, can you make a recap?
God bless
just
you.
To give a brief summary of everything. The first thing is for lecture 2. Let me focus on exam. For lecture 2, what starts your lecture 2 is pavements. So everything is basically theoretical, pavement design. So from page 1 to 7. So he said we should read page 1 to 7. He's going to cover a whole question. I don't know. I want to bring it. Probably more than one question because based on the past question I just saw now, I think it's split into 2 separate questions. So he asked us to make sure that we should read page 1 to 7. That is all we need for pavement. Then you cannot go and learn CBR. Because CBR will cover is the number 1 question. What Seyi just solved now that you are going to do for your feature load before you now do your subgrade. That one is the number 1 question. So automatically, you already have 2 questions started. Then he mentioned that cumulative ASU load will come out. But this cumulative ASU load, he mentioned it to me last week before he says the question. So that was why, because during our conversation with him yesterday, cumulative ASU load, we didn't really he didn't say anything about it. So I'm going to confirm that will come out, but he mentioned it specifically that will cover one question on his own. But I'm going to confirm for me if we are to do the calculation. Hopefully we can try to get him not to tell us to learn the calculation since he didn't teach us. So, but I'll get back to the book on that. So he said one question will cover cumulative ASU load. Just to recap again, page 1 to 7, pavement design, one question. This same material contains the CBR that Seyi taught us. So if you can go through this material, you see the CBR that Seyi taught us, that will carry one question. Cumulative ASU load will also carry one question, but you are expected to neglect Bosnick theory also. Anything on this Bosnick, anything under this Bosnick theory, do not read it. Instead, it's not putting that for exam. I don't know if that makes sense now.
Okay.
Then for lecture 4, all you have to read on this cover is the theoretical aspect. Don't read the calculation. Calculation is not coming out on cover. That is all you have to read. So lecture 4 is just 7 pages, excluding the calculation. That is basically it. I don't know if that is clear.
Wait, Taiwo, you said this after the question she solved, that theoretical part following it. Are we to read that one?
Look at that question. See, last question, he didn't ask any theory. But yesterday, he said we should try to know all those percent that he can ask us to explain or something like that. So anything under CBR in that material, me too, I've not read the material. So anything under CBR in that material, read it. You get what I'm trying to say? But from this past question now, he didn't ask any theory.
Okay.
So Taiwo.
All right, thank you.
Mentioned something. Hello?
I can hear you, Mayowa.
So you mentioned something cumulative ASU load. That one is under lecture what?
It's under that lecture 2 is carrying 3 questions. Cumulative ASU load, pavement design, and CBR. So, but for the cumulative ASU load, I will confirm if you have to read the calculation under it for me.
No, okay, I know I'm asking because I can't see cumulative ASU load on my math. Page what? Okay.
I'm looking for it. Calm down. I think cumulative ASU should be before Bosnick now. I saw something.
Yeah, before Bosnick theory, before that.
Exactly. I think it's under estimation of traffic also. And I think there's 1 to 7 already covered 2 questions there. Yeah, I think that was why I told us 2.
Scroll up. And this is it.
Makes
Just
sense.
pass it.
Oh, I see now. So basically, so 1 to 7 already cover pavement and cumulative as load. You know, I've not read the material. He just said that, okay, we should focus on one. So if you check the pavement itself, stop at page 5. That one will cover one question. Then this estimation of traffic is the cumulative as load. So from page 5 to 7 is all you need to know on cumulative as load. So that is a short calculation there.
But lecture 4, so far lecture 4, you only gave us one question from
that one is
lecture
just
4.
one, it's just covered, yes.
All right, thank you.
Yeah. So let me repeat that. Page 1 to 5 is pavements. 6 and 7 is cumulative as load. They expect you to know those one will cover 2 questions already that way. I don't know if that makes sense. Then if we go again, after this cumulative as load, they are going to do something on Bosniak. Don't read Bosniak at all. Just go straight to your CBR. I don't know if that makes sense. Just go straight to your CBR. Then that will be 3 questions. Then you go to lecture 4 to just read all the theoretical part except calculation there.
Yeah, wonderful. Thanks.
Yeah.
Thank
Then I'll send everything to the group chat.
God bless Adewumi and laziness. Love it.
And the last thing is.
Okay, so now when you're done, I'll ask my question.
Okay. Please. You said the last thing is what?
The last thing is that graph that Seyi used to solve. That one that I sent to the group chat. You are expected to print it out and bring it to the exam.
You can tell Mr. Abi to help us print it now.
You are in school. You can tell him for me, sir, with all due respect.
Yeah, I can even tell him that he should print everything for us. Then we'll get it before
Yeah, exactly. That makes sense.
Okay, like that, Samson. Nice one.
Best cost rep ever.
You will pay me.
I love you, Samson.
All right. So we'll try to upload it today on Feeling, so people that don't attend can access it.
Okay. Taiwo, sorry, you said Taiwo.
Yeah.
So you said you send a streamlined. Are you still sending that one? A streamlined version of
streamlined.
You send lecture 1 to 4 and the past question.
See, like everything I've been streamlined. I will send everything on all this on my screen. These 5 materials I will share to the group now.
Okay.
Please, I have a question.
Okay.
Could that be?
Please, before this Bosniak elastic theory and after the cumulative stuff, there's like one section that you didn't talk about. We are not supposed to read that too, right?
He didn't mention that. He didn't mention anything on that. You know.
All right.
I couldn't get anything because you may probably just factor of safety look at it.
But
after
you can like to read it. You should read it because you are sitting now beside me. So read it.
I think you should actually read it. You should not just touch. You should read everything apart from the Bosniak theory stuff. But the ones that questions are going to come out from is from page 1 to 5, and I mean from 5 to 7 too. But you can just glance through that one.
Exactly. All right. Yeah, I think that should be any other question.
Taiwo.
Yeah.
Sorry. I just wanted to get a recap based on the tests. He said we should for lecture 3. He said we should read pages 1 to 11. Like skim through it, Abi.
See, I'm going to send the initial lecture 3 with you guys is extremely much. So I'm going to send a new lecture 1 and 3 now. That's all you need to skim through for test. Read for test.
All right. Thank you very much. That's all.
Thank you. We're expecting it.
All right. Yeah. Thank you so much, Seyi, once again for your time, and thank you so much.
Thanks, Taiwo.
Thank you, Seyi and Taiwo. Not too much. Well done.
Thank you, Seyi.
Please, what other tutorial are we supposed to have?
We are trying to see. We're trying to.
Manhole, please.